Welcome to a partly cloudy day in Thailand and batteries. With the box of batteries arrived, we can now start to work on building a test battery pack. This is hot off the printer. It is a 2x8 cell holder for 21700 cells. I've got just a couple in place now. They're nicely snug in the holder, but we can't actually wire this up and put it in the bike yet because I haven't proven to myself what the capabilities of the batteries are. And that's where this comes into play. Alert viewers will remember this. It's basically a multi-cell battery tester. It charges, it discharges, and it also measures the capacity of the cells that you can connect up to it. To do that, you plug a connector into here, and that's what I've done. I've spent the last few days building this. It's 3D printed. Oh, I forgot to paint the red on the numbers, but they're actually numbered 1 through 6. This is 3D printed. The batteries fit inside, and this was a bit of a nightmare to build because I couldn't find any 21700 holders, so I had to make my own, but I used the negative and positive ends from some other battery holders that I found, but I had to cut them up and glue them in place. And then they're designed for batteries that have a little button on the end. These do not have a button. They're completely flat on the top. So I had to solder in a bump into the positive terminal so the battery would make electrical contact. But we're beyond that problem. The connector, as you see, is wired up as it shows in the manual. This is the most positive end of this pack of 6. And it has a positive wire which charges from the tester from here. There is a most negative wire which is here connected to the most negative terminal. That connects to the black connector right there. And then this plug plugs into the box. And the box measures and balances each cell through this connector. And that's all as detailed on this one small picture on page 18 of the manual. It actually tells you how to wire up your batteries. So I think we're in good shape. I just need to read this manual and figure out how to make it work, and we'll get started on testing the cells. The first thing we need to do is match up our batteries against all the types of batteries that the box knows how to deal with. Clearly we don't have nickel cadmium or nickel metal hydride, and we don't have lead acid. So that leaves us 4 lithium based cells. Now we're looking to match up a standard voltage of 3.6, maximum voltage 4.2, charging rate of 0.5 C, which is 2 amps, and a voltage cutoff level at 2.75. So this lithium high voltage one is out. That's way too high. The voltage level for lithium iron phosphate is out because that's way too low. So we're looking at basically one of these two. And I'm going to go with the one that's labeled lithium ion because everything else is very close, but it matches better because we need to go down to 2.75 volts, whereas this LiPo only goes down to 3 volts. But lithium ion goes to 2.75. And I think I'm able to adjust these values, but I'm going to take this as my baseline. Okay, I've been working with the settings in this box, and let me tell you, it is not the most user-friendly system. It's extraordinarily weird, and this manual is roughly terrible. But I think I've got things set up. So what we do here is I've got lithium ion, even though the manual says, focus, you fuck, lithium ion. In the software, it's LiO, and I initially didn't make that connection, but inside this box, it's LiIO is the one we want. Okay. And what we want to do is go into here, and there's several different things you can do. You can charge. This is part of the annoyance. Sometimes you hit this for settings, sometimes you do it, sometimes this increments and decrements values, sometimes it goes from one menu to the next. So we can charge, balance, fast charge, put it in kind of a sleepy storage mode with a safe voltage, or discharge. Now, for each of these, you're allowed to set your current that you want to flow through, because the box doesn't know your particular cell's charge and discharge C values. So say I go in here and I say I want to charge at 2 amps. That is 0.5 C for my batteries, which is right in line with what it wants. Now, say I want to slightly adjust the default value from what things are here. Nope. When I pop over here and say I wanted to charge it to 21.8 volts or 22, I think I can increment and decrement. No, it's incrementing and decrementing by an entire battery. So this says 6 in series. It won't let me go up. If I go down, it's 5 in series. We change to 18 volts. 14, 10, 3, 2, 1. So it's saying the nominal value of what they say in this nominal value here. But that's not really what it means. This is basically, if they just got rid of that voltage number and say, I want to charge 6 cells in series at 2 amps, it would remove so much of the confusion, because when you actually go into charge mode by holding this down, and you can see on our meter here, now here's another weird thing. It says, I'm sensing that you only have 5 batteries hooked up, but you told me you want 6. But is that okay? Do you want to go ahead and do that? And you can say, yes, go ahead and do that. Now we're jumped into charging mode. So we're charging 6 series lithium batteries at 2 amps, and you can see the meter here, which is connected to the same place that this is reading its value, 23.17, 23.18. After it settles down a bit, they track pretty closely, and I think this is the number of minutes and seconds, and this may be the number of milliamp hours that's going in, but that's fine. But you can see it said at 3.6 volts and 6 cells, it's going beyond that here. It's actually going to 4.1 or 4.2, I don't know which. That's what it's currently increasing the battery voltage to. And you can see this number is going to go up slowly as we're going up that graph I showed you in the last one. So that when it was showing us the voltage thing last time, it was a complete red herring and it drove me nuts. So I want to stop this, because really my goal today is to bottom balance these 6 cells. There are 2 worlds of lithium battery balancing. One is you get a little circuit board from China that you have no idea who the vendor is, the quality of the components, electrically how it works, other than it tries to balance the cells by running energy through a resistor, which would be controlled by a transistor that the brain box fires on and off. It's basically heating up this resistor to throw power away from each of the cells so that they, instead of being like this, they eventually come together and they're all at the same voltage level. This throwing away energy as heat through little tiny resistors soldered onto that board has caused fires. When the board itself goes bad, it will take down your battery pack. It will drain one or more cells down to zero to the point where they're destroyed. Anyway, so if you can't tell, that's the style I don't like. The style of battery pack management and initialization of your battery pack is called bottom balancing. You want to take all the cells down to a certain level before you even put them in the car. This is what we're doing now. On the test bench, you bring all of your cells down close to the bottom level. Now this thing is saying 2.5 volts per cell or higher is the minimum discharge cutoff. So that's where this box is going to cut off. I'd be happy if I could get it down to 3.0 volts or 2.9 volts because my cells want to stop at 2.7. So we go to the, okay, we're not going to balance yet. We're not going to fast charge. Okay, so I want to discharge at 2 amps, 0.5C, which is the spec on the thing. Again, 18 volts is not where I want to discharge to. I want to go below 3 volts per cell. But if they would just say, we're going to discharge your 6 series of cells down to this number, and this scares me a little bit because I'd like to be around a little higher than that, but it's not adjustable. Again, if I go in here and I want to change my values, I'm happy with 2 amps. But I can't very small increments of my discharge because it's saying how many do you want to do, 5 or 4 or 3, or I want to do 6 cells. So I hold this down and that initializes the discharging. It says, now it says, I think you've got 6 batteries in series and you told me you had 6. So yes, let's go ahead and do that. Now, what we want to do is take our 6 cells and you can see that we're taking 0.4 amps out of the pack now and the voltage is dropping. 3 volts per cell would be 18 volts. And I have no idea what this thing is going to do. Is it going to take it down to 2.5 volts per cell or higher? I can't find a way to set this target minimum voltage value through the horrific menu system, and the entire picture of the menu system is right here. Now there's a few, but they basically go through for other things, and it doesn't tell me anything about how to change that. So I'm just going to watch this like a hawk. I'm going to leave the camera running and then I'll do it in fast forward for you. So my goal is to stop the discharge when this hits, we'll call it 2.8 volts times 6. That's 12, 6 and 8 is 48, so I think it's 16.8 volts. I'll double check the math, but that's what my target's going to be. 2.8 volts per cell, and then I'll do a balancing function. And the batteries aren't even warm yet. We're taking half an amp out of them. The pack voltage is slowly coming down. 14 milliamp hours maybe have been taken out of the cells. So everybody take a deep breath and we'll just let this go. Okay, the tester, it's cooled down a little bit, still warm to the touch. It's only drawing 1/10 of an amp, and it seems to be hovering at 18.00 volts, even though my meter says 17.57 volts. It's only pulled 294 milliamp hours out of 6 cells to get it down to 18 volts. I don't trust this thing as far as I can throw it, and I could throw this thing a long way off the top of my condo. I've been watching some YouTube videos from other people who have this. Apparently, if you go out of lithium ion mode into NiCad, you can actually adjust the bottom cell voltage, and it'll take it down to that. So maybe that's a way to get me to my 2.8 or 2.9 volt bottom target. But this has sure been an adventure on my first charging day or testing day. I'm thinking about just buying some big power resistors and taking them down by hand, each one, get it down to 2.8 or 2.9 volts, and I mean like 2.8000 volts, and run through everything I need in my pack, and then just go from there. Because this thing, not great. Look what happened when I put it into balancing mode, just for fun, on a whim. 2.40. What the frack? Let me test each cell individually with my fluke meter and see what it says. Okay, I'm going to test each one in turn on the fluke. There's battery cell 1 that the iMAX said was 2.40, 3.082. Next cell, 3.079. Next cell, come on, touch, 3.059. Next cell, 3.053. Next cell, 3.067. Next cell, 2.565. Okay, maybe that's a dodgy one. Let's take this out of the holder. If this is bad from the factory or I damaged it somehow, 2.582. That's definitely too low. We're going to put this battery in the special box because there's no way that should be that way. It's not 2.4, but it ain't good. Okay, here's the next one out of the box at 3.48. So we're going to put this guy in the pack and hopefully get ourselves back to a healthy place. Okay, I've now set it up to discharge only one cell. We're taking it down to 3 volts, pulling 1.3 amps out of the cell, and you can see the voltage drifting down. It's getting a little warm. I want to get this down to approximately the same place those other cells were at. Okay, it's the next day, and after a lot of YouTube video watching, which there are hundreds on this thing, I've discovered a few things. One, this is a clone. You expect to pay good money for something, and this is what shows up, and it's a piece of crap. And frankly, the original one from the factory is also a piece of crap because it's almost impossible to correctly calibrate. Now, who do I trust? This thing or my 3-digit fluke meter? So this is my magic number right here. I want every single battery in my pack bottom balanced to 2.900. The vendor asks me to go to 10 millivolts, which means 2.90, and then the last digit doesn't matter. But being the anal retentive idiot that I am, I want 2.900. Oh, and we just timed out on the meter, and bring her back up. Excuse the noise from the 3D printer. But, so I can't get that level of precision out of this piece of junk. And frankly, this is one of the most popular things on the market. Anything better than that is hundreds of dollars. You'd think there'd be something in the middle that actually worked. Anyway, so my long-term plan is to use this to bulk discharge 6 cells at a time and get them down to around 3 volts. Then I made this magic piece of crap right here today with 2 resistors. This one's 4.7 ohms, which allows 0.6 amps to flow out of the battery. This one is 2 ohms, which allows 1.3 amps to flow out of the battery. These are both 10 watt power resistors. They're safely within the power window and they get a little toasty. And I've got this switch. If I click one, it puts the 4.7 ohm resistor in the circuit, which is that slow discharge. If I click 2, it puts this resistor in the circuit, which is fast discharge. But the clever among you will realize that not only is there I was looking at resistance going forward through the switch, but there's also resistance coming back. So say I switch it to 1, there's 0 ohms or close enough through this resistor to the battery. But if I switch it to 2, there's 7.5 ohms through here, which is, oh, look at that, 6.7 plus or minus a few percent. So I could solve that by putting some big power diodes on the end here. In the end, I don't care. This is just to get me a way to take some tiny bit of charge out of the battery at the end of the cycle. So now you can see we've drifted up to 2.904. So what I'm going to do is get these both in the shot. I'm going to go slow discharge, click, and we're dropping to 2.8, and I've got to click it back that fast and take it out of the circuit. And this is going to drift all the way back to right up around 2.9. In lead acid batteries, we call this the Poikert effect. I think that's how you say it, Poikert. There is a tiny amount of this in the lithium chemistry. And I was just trying to get that last 4 thousandths of a volt out of the cell because that's how I roll. Anyway, so I plan to get all of these guys down to 2.900 volts. First bulk discharge with this, and then fine discharge with this. Put them in this box, and then we'll start talking about my battery pack. Oh, look at that, 2.899. Come on, baby, yeah, 2.900. It's probably going to go back up to 0.1 or 0.2, and I could live with it, but all right. Happy battery. Don't buy this. Vader out. Okay, welcome back to the final clip in this video. Again, excuse the 3D printer. And you can see I've got a piece of blue tape covering up the switch. Don't ask me why that's there, but just remember back to the Apollo 13 movie when Jack Swigert put a piece of tape over one of the switches so that he didn't prematurely do something very bad that would kill the entire crew. So this is my Apollo 13 protection system. Now, last night I bled down all the cells to 2.9 using a combination of the fast resistor and the slow resistor. This morning I woke up and they had bounced back up, usually to about 3.05 or 3.1 volts. I did another round of bleeding them down to 2.9. That was about 6 hours ago. Then I just recently did another bleed, but basically on the slow button, it took about 2 or 3 seconds worth to get them down. So let's just take a look. We'll pop this guy in here, and we're at 2.898, 899. That's okay with me. I'm off by 1,000th of a volt. My OCD allows me to do that. Let's try the neighbor cell. 2.900. Awesome. Oh, not 0.1. All right. So this set of 20 is basically primed and ready to go. I'm going to build it up into this pack, and we'll get it ready. And we are still purely at the testing stage. I'm going to bring the bike upstairs. We're going to put one pack of 60 volts into it. I'm only going to be able to get, I'm going to try 4 amps out of this. We can try up to 12. If you remember, 3C was the maximum for these cells. And it's basically a learning exercise. I'm not going to be happy until something goes wrong and I learn from that, and then I figure out what to do next. So, signing off for this video. The next video will be, this build will be complete, then I'm going to charge it, and then I'm going to test it in the bike. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.